We can use trigonometric ratios to solve problems in the real life. And in order to do that, we have to define and understand angles of elevation and depression. So what are they? Let's consider this man. When this man is looking straight forward, his line of sight is this horizontal. Now let's say he wants to look up and see this aeroplane. The angle by which he lifts his eye so that his line of sight spots the aeroplane, this angle is called an angle of elevation. Now let's say that this man wants to look at this dog. His line of sight is originally on the horizontal, and the man dips his head so that his line of sight catches the dog. In this case, we say that the angle by which the man dipped his head is the angle of depression. Now, let's consider a person sitting in the aeroplane. Their line of sight would be the horizontal. Now let's say they want to look at and see this man. So they will have to dip their head because they are higher up, and this would be the angle by which they dip their head, and this would be an angle of depression. Similarly, if the dog wants to look at the face of the man, the dog originally looks horizontally, and then to see the man he has to lift up his eyes, so that would be an angle of elevation as far as the dog is concerned. So for this man looking at the aeroplane, this is an angle of elevation, but for a man in the aeroplane looking at this man on the ground, it's an angle of depression. The same applies for the dog. But it's interesting to note that since the horizontal lines, the three horizontal lines, are parallel, then those two angles are equal because they are alternate, and those two angles are also equal because they are alternate. So for 2 points, A and B, for example, the angle of elevation from one to the other is equal to the angle of depression from the first to the second. So how can we deal with these problems? Consider, for example, a building whose height is h, and we don't know its height, and we want to calculate it. We can measure a distance, say 60 meters away from the building, and then we can measure the angle of elevation using a compass or a device that can be loaded on your mobile phone, which we'll talk about later, and we can measure this angle as 12 degrees. So what is the height of the building? The idea is identify a right angle triangle, and obviously the building is upright, so this is a right angle here, and the height is the unknown. As far as this angle is concerned, h is the opposite and the 60 is the adjacent. So tan 12 is h over 60. So h equals 60 times tan 12, and that equals 12.8 meters high. So we have calculated the height of the building without actually having to measure it. Let's say that we have a flat ground and a tree, and in this tree there is a bird here that is sitting on a branch that's 6 meters high above the ground, and this bird is watching a cat. The cat is here and here is its tail. Now the bird usually looks horizontally, but the moment he realized there is a cat around, he looked down and watched the cat, and the angle by which the bird dipped his head was 16 degrees, so this is an angle of depression. The cat saw the bird and decided that it might be a nice dinner. So it looked up, and the angle by which it elevated its eyes is 16 degrees, so this is an angle of elevation. Now the bird has to decide, should I fly away or not? And that perhaps depends on the distance d, the distance between the cat and the base of the tree. If this is a short distance, that means that the cat can climb up and catch this bird. So this bird, being very mathematical, decided to do the calculations. He thought of this right angle triangle, and he said, okay, this is the distance that I want to calculate, and this is an angle of elevation. As far as this angle is concerned, 6 is the opposite, d is the adjacent, so tan 16 is the opposite over adjacent. So d equals 6 over tan 16, and that, if you work it out, let's do that together. 6 divided by tan of 16, and that's 20.9. Now, based on previous experience, the bird will decide whether to stay on the branch or fly away. Now, to put it in a more realistic way, when you look at an angle at a building and you want to calculate an angle of elevation, you're not really measuring the angle of elevation from the ground. Here is a person measuring the angle of elevation of the top of the building, but this person is, let's say, 1.7 meters high, so this has to be taken into consideration. In this case, this person, when he looks horizontally, well, he knows that he's 42 meters away from the building, and the angle of elevation of the top of the building is 9. So if we think of the right angle triangle, it's here, it's the red one. And if this is the angle 9, this is the opposite, and this is the adjacent, so it's tan 9 equals L over 42, and by cross multiplication we find that L is 6.75. Let's do that together. 42 tan 9, 6.65 to 3 significant figures, and the answer is in meters, of course. But the height of the building needs to be calculated by adding the length that we calculated in addition to the height of the man, which is the 1.7. So that gives you 8.35 meters as the height of the building.